Hello everyone. Today we are going to discuss a new topic that is measure of central tendency and measure of dispersion. So measure of central tendency oblique statistical averages. A measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within that set of data. Means what? The measure of central tendency shows the center of data, also called measure of central location. The mean, often called as average, is mostly likely the measure of central tendency, but there are others such as median and mode, also known as average. As average is an attempt to find one single figure to describe whole number of figures. The word average implies a value in the distribution around which other values are distributed. It gives mental picture of the central value. So commonly used methods to measure the central tendency are as arithmetic mean, median, and mode. Let us see what is arithmetic mean. So arithmetic mean is defined as the sum of all observation divided by total observation, and it is represented by x bar. Let's see, x bar is equals to sum of xi upon n. N is total number of observations. Now let us understand with this example. Obtain the arithmetic mean of marks scored by a student in 8 unit test of second year MBBS class. So here are the 8 observations of marks of different unit tests, and the formula of arithmetic mean is sum of all observations divided by total number of observations. So here total number of observations are 8, and now adding all observations on a numerator divided by total number of observations. So after solving this division, answer is 65. So therefore the average marks of second year MBBS classes are 65. Let's see another example. Calculate the mean of the following series of data set. So here is the we have a series of some observations, and for calculating arithmetic mean, first we have to add all observations on numerator in the formula of arithmetic mean divided by total number of observations. So 1253 is the sum of all observation divided by total number of observations are 10. So 125.3 is arithmetic mean. Now let us see the second type of measure of central tendency, which is mode. It is another measure of central tendency developed to overcome the drawback of arithmetic mean. Apart from this, in some situations, mode is the proper average. The definition of mode is the observation with maximum frequency or the most repeated observation is called as mode. मतलब डेटा में जो मोस्ट रिपीटेड ऑब्जर्वेशन होगा वो होगा हमारा मोड. For example, in case of election result, a political party with largest votes, that is maximum frequency, is considered as representative. Thus, it is mode or modal opinion. In this situation, mode is appropriate average. Uh, if we see the second example, in a titration experiment, out of 3 readings, a repeated reading is taken to be a final reading. It is mode and not to be a arithmetic mean. In some types of situations, if we see below is the data of marks obtained by 63 students, find the mode of the following frequency distribution. So here we have given a frequency distribution, that is x means the marks obtained by students, and f means the frequency, that is data shows here two students are that who given 10 marks, 5 students given 11 marks, 10 students, given 12 marks, like that. Now, if we see, since maximum frequency is associated with observation 30, that is 13 marks obtained by 21 students. So here the maximum frequency is 21. So the modal observation is 13. Let's see the second example of mode. Here we have given the data of diastolic blood pressure of 9 individuals. So observations are 86, 76, 80, 86, 70, 96, 86, 76 and 86. Now obtain the modal value of diastolic pressure. So if we see here, 86 is occur 4 times. 76 occurs 2 times, 80 occurs 1 time, 96 occurs only 1 time. So maximum frequency of observation is 86. 86 occurs 4 times. That's why 86 is our modal value here. Now merits and demerits of mode. If we see the merits, number 1, it is applicable for qualitative type data and quantitative type data. It is not affected by extreme observations. It can be determined even though distribution has open-end classes. It can be obtained graphically also. So if we see histogram shows the most frequent observation on a top. The histogram is basically uh, histogram is best tool for representing the mode. Now the demerits of mode. It is not based on all observation. We miss some observations for consideration. It is not capable of further mathematical treatment. So there is no mathematical or logical formula we use here, and it is not rigidly defined. Now, third and last measure of central tendency is median. So median is the middle most observation in the data set when the observations are arranged in increasing or decreasing order of their values. So, and median is the central value of data set. It divides the data into 2 equal parts. There are equal number of observations above as well as below of the median. It is also called as positional average. Let's see the example. Following are the temperatures recorded in a certain city, observed in a certain week. So here are the observations. Total observations are 1, 2, 3, 4, 5, 6, 7. 7 observations here. First we arrange the data into order, into an ascending order. Since n is equals to 7 is odd, then we get a formula. Median is equals to the value of n plus 1 divided by 2th observation. So n is equals to 7, then n plus 1 is 7 plus 1 means 8 by 2, that is 4th observation. So the value of 4th observation is 37. If the number of data sets are even, then we have to use this formula. Median is equals to the value of n by 2th observation plus the value of n by 2 plus 1th observation divided by 2. Let's see, let's understand with the example. Calculate the median of the following series of data sets. So here, total number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number of observations are even. That's why we use the second formula here. First, arrange the data set into ascending order or descending order. So the total number of observations are 10. We use the second formula, the value of n by 2th observation plus the value of n by 2 plus 1th observation divided by 2. So n is equals to 10. That's why n by 2 is 10 by 2, that is 5th observation, and here 5 plus 1, that is 6th observation by 2. So 5th observation in arranged data sequence is 125 plus 6th observation is 125. So 125 plus 125 divided by 2, that is 250 by 2. Therefore, median is equals to 125. Now, merits and demerits of median. Let's see the merits. It is to it is easy to understand and calculation. It can be computed for a distribution with opening classes also. It is not affected due to extreme observation. It is applicable for quantitative as well as qualitative type data set. It can be determined graphically also. And now the demerits of median are: it is not based on all observations, hence it is not a proper representative. It is not as rigidly defined as the arithmetic mean. It is not capable for further mathematical treatment. Now, comparingly, if we talk in what situation median is used rather than arithmetic mean. So, arithmetic mean cannot be calculated for qualitative observations like debating skill, honesty, blindness, and also if a frequency distribution includes opening class. In this situation, arithmetic mean does not exist, and it is affected by extreme observations also. In previous slides, we can see the measures of central tendency and their types. Now we are going to discuss measures of dispersion. So measures of dispersion is a tool which summarizes the internal variation or variation within the observations. Commonly used methods to measure dispersion are range, variance, and standard deviation. Simply, if we say measures of central tendency shows the center value of data, and while measure of dispersion shows the amount of variation in the data set. The very first measure of dispersion is range, and it is defined as range is the difference between the smallest and largest observation in the data set. For example, we have given some observations. Uh, Here, smallest observation is 14, and the largest observation is 106. So the range is the difference between largest observation and smallest observation, that is 106 minus 14 is equals to 92. So here range is 92. Now, what is variance? The variance is average square deviation taken from the arithmetic mean. If we see the formula, that is variance is equals to summation of I from 1 to n xi minus x bar bracket square upon n. If we see uh, the formula, it is clear that is numerator is sum of some observation divided by n, means what? It is average, and average of what? That is mean square deviation from central values, that is x bar. So xi minus x bar is deviation, and it is a square deviation, and if we divided by n, we got a variance. And now, what is the standard deviation? The positive square root of the average square deviation taken from the arithmetic mean is called as standard deviation. And what is the formula for that? It is represented by sigma, and sigma is equals to square root of variance. Now let us understand variance with this example. Marks obtained out of 100 by 10 students in test are as under 85, 45, 54 up to 41. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 observations are here. Now calculate variance and standard deviation from the above data. Before calculating variance, we need to we need to draw a table of contents like x means variable, x minus mean means first we calculate average from all these observations. Then we subtract mean individually from all these observations. Then we square in the third column. We square this difference. And finally we total that square difference here. So it will become easy to calculate the variance. That is, if we see the numerator of variance formula, which is sum of x minus mean bracket square. So in previous slide we can see in the third column we already different we already calculate all the different squares. Um and one thing here is we have to note, that is the denominator is n minus 1. So there is a situation, if our total number of observations are less than 30, then we have to divide variance formula with n minus 1. uh, then it becomes, so the total sum of difference square is 3200, and divided by n minus 1 means 10 minus 1, that is 9. So calculations, after calculating this deviation, 355.56 is the variance. And now for standard deviation, simply we need to square root of that variance, that is square root of variance is equals to square root of 355.56, that is 18.86 is a value of standard deviation. Here is another example. Calculate various measures of dispersion for the following fasting blood glucose values in milligram percent in 10 diabetics. So if we talk about range, then we need to search a smallest observation, that is smallest observation here is 85, and the largest observation is I think 120 is the largest observation. So range is equals to largest observation, that is 120 minus 85. So 35 is the range. Now for calculating variance, we need to first calculate the arithmetic mean. So here sum of all observations is 1000 divided by number of observations are 10 here. So 1000 divided by 10, that is arithmetic mean is 100. So for calculating the numerator value, that is xi minus x bar bracket square, that is individual observation minus mean bracket square, we need to uh, draw a table, that is in the first column of table we arrange all observations. In second column of table we need to subtract arithmetic mean individually from these observations, and in the third column simply we get squares of these observations, these squares, these differences, square of these differences. So we got a value, that is xi minus m bracket square, all observations sum here. Now variance is equals to sum of mean square differences, that is 1500 divided by n minus 1, that is 10 minus 1. So 166.667 is the value of variance. Now for standard deviation, we need to simply square root of the variance value. So 12.91 is standard deviation. Thank you.